Today we're going to look at the intermediate value theorem. And our objective is to use the intermediate value theorem to show that f of c equals some number. Okay, so the idea behind the intermediate value theorem is pretty straightforward. So we have 2 points, A and B, that are connected by a continuous curve. We have 1 point below the line and 1 point above the line. So if the function is continuous, then there must be at least one place where the curve crosses the line. Obviously, because we cross the line to get from A to B. That's literally what the IVT says. So if f is continuous on some interval, and k is any number between 0.1 and 0.2, then there's at least one x value where f of that x value equals k. So let's take a look at a couple of examples. We want to use the IVT to show that the polynomial has a 0, which means that we want k equal to 0 on that interval. So the way that we do this is first, we double check that it's continuous. So the first part of our verification is to say that we know f of x is continuous on the interval 0 to 1, this closed interval. Honestly, this particular function is everywhere continuous, but there may be cases where that's not true. So we state that it's continuous. Then we check f of 0, the first value in the interval. If we plug 0 into our function, we have 0 cubed plus 2 times 0 minus 1. So f of 0 equals -1. We check the other value, so f of 1. And if we plug 1 into the function, we have 1 cubed plus 2 times 1 minus 1, and we get 2. And then we state the IVT. So since f of 0 is less than our k value of 0, and f of 1 is greater than 0, there must be some value c where f of c equals 0. These are the 3 pieces that we have to show every time we are verifying the intermediate value theorem. And then we have to find the value that guaranteed by the theorem. So looking at these new examples, we want to verify that the IVT applies and then find the value of c guaranteed by the theorem. So first step, is f of x continuous on that interval? For this example, the answer is yes, because it's everywhere continuous. So we say that f of x is continuous on our closed interval 0, 5. Then we want to find an f of c value where k is equal to 11. So we'll check our endpoints, and we'll do f of 0. If we plug in 0, we get a y value of -1. If we do f of 5, it's 25 plus 5 minus 1, which is 29. So the IVT applies because f of 0 is less than 11, and f of 5 is greater than 11. So there must be a c value such that f of c equals 11. Now we need to find that c value. So since there isn't quite enough space, we'll move over to the next slide. Actually, we'll just move over to the side, and we'll find the x value where x squared plus x minus 1 equals 11. So we'll use our newfound algebra skills to solve this. We would subtract 11 and get x squared plus x minus 12 equals 0. This factors to x plus 4 and x minus 3 equals 0. So x equals negative 4 and 3. So there are actually two c values where f of c would equal 11, but only one of them is in the interval 0 to 5. So we say that c equals 3 because 3 is between 0 and 5. All right, for example number 3, we'll go through the same process again. This time we're looking for a c value so that we have a k value of 0. First, we check continuity. Is f of x continuous from 0 to 3? The answer is yes. So we write that f of x is continuous on our closed interval 0, 3. Next, we check f of 0, that's 8, and f of 3, we plug in 3, we get negative 1. Yippee! IVT applies. Since f of 0 is greater than 0, and f of 3 is less than 0, there must be a c such that f of c equals 0. So now let's go ahead and find it. So we'll say that x squared minus 6x plus 8 is equal to 0. We can factor that to x minus 4 and x minus 2 equals 0, x equals 2 and 4. But we're on the interval 0 to 3. So the 4 is excluded because it's not in that closed interval, and we say that c equals 2. All right, two more examples. First, we check continuity. Is f of x continuous on the interval 0 to 3? The answer is yes. Then we check our endpoints. What is the value of f of 0? When we plug it in, we get negative 2. What's the value of f of 3? We plug that in and we get 19. So since negative 2 is less than 4 and 19 is greater than 4, IVT applies. So the way that we write that again is, since our two endpoints, do what they need to do, there must be a c value such that f of c equals 4. And then we go ahead and find it. So we'll roll over to the side so we have some space to work. And we will set x cubed minus x squared plus x minus 2 equal to 4. We can use synthetic division or we can use Desmos. I'll go ahead and use Desmos. Set y1 equal to x cubed minus x squared plus x minus 2, y2 equal to 4. When we look at the intersection, we get an x value or a c value of 2. All right, moving on to our last example. First, we check continuity. And we are concerned because this is the first example where we have a discontinuity, specifically a vertical asymptote at x equals 1 from our denominator. But then we look at our interval, and we're from 5/2 to 4. So we're back in the land where we're continuous in an interval. And we'll say that f of x is continuous on that closed interval 5 halves comma 4. If you want, you can note that it's discontinuous at x equals 1. Then we'll check our endpoints. We have to do f of 5 halves, and when we do that, we get 35 6, which is 5 and 5/6. F of 4, we get 20/3, which is 6 and 2/3. So since one value is below our k value and one is above, we're in good shape. And we can state that since f of 5 halves is less than 6, and f of 4 is greater than 6, there must be a c value such that f of c equals 6. And now we'll go ahead and find it. We'll use algebra again just for fun. So we'll set our function x squared plus x over x minus 1 equal to 6. Multiply by the quantity x minus 1, so we'll get x squared plus x equals 6x minus 6. Set it equal to 0 because it's a quadratic. X squared minus 5x plus 6 equals 0. Oh, happy day, it factors to x minus 2 and x minus 3. So x equals 2 and 3. So there are two values where this rational function equals 6, but only one of them is in our interval from 5 halves to 4. So we say that c equals 3 because it's the value that's in our closed interval. As always, let me know if you have questions.